Good afternoon, class. This is Mr. Precella. Let me turn on my microphone. Let me find it in here. Yeah, there it is. Okay, you know something? I've been running around so much today, so I'm tired and hot. So if you'll excuse the informality, I'm taking off that jacket. And today we're going to look at circles, and we're taking an algebraic approach to circles. We make the assumption in a college algebra class that you're familiar with the geometry of a circle. You know what a circle looks like. You know it has some point right there in the middle, and that middle point is called the center. And we denote the center of a circle using the coordinates h, k. That's just standard practice. Pretty much all algebra books use hk to denote the center of a circle. The distance from the center to the outer edge in any direction is called the radius. I'll denote the center with the letter C, obviously. I'm going to denote the radius with the lowercase letter r. And as I said, if you start at the center and go to the outer edge in any direction, all of those distances are the same. Hence, that's the radius, the distance from the outer edge of the circle to the center of the circle. But since this is an algebra class, as I said, we're taking an algebraic approach to circles, which means we better have an equation thrown in here. We have something called a center radius form of a circle. If you know the center and the radius of a circle, you can write the equation in the form x minus the x coordinate of the center, which is being denoted with an h, quantity squared, plus y minus the y coordinate of the center, quantity squared, equals the radius squared. If you know the center of a circle and you know the radius, you can write an equation. Realize that h, k, and r are numbers. The variables here are x and a y. The h, k, and r are all numbers. And to illustrate, let's see, number 1. We're told to find the center radius form of the equation of the circle when the center is at the ordered pair 0, 0, and the radius is 7. And then part B, they want us to draw the graph. As long as you know the center and the radius, then you don't need to write an equation to be able to graph the circle. They could have said A, graph the circle, and then part B told you to write the equation. But they want us to write the equation first. Let me write this down. Number 1, they tell us that the center is at the ordered pair 0, 0. Centered at the origin, that's always the nicest type of circle. You'll see what I mean when we're drawing it. The radius is 7. And let me switch over. Oh, there. This doesn't belong there. There. And we know that the center's denoted HK. That means H is equal to 0 and K is equal to 0. So we know that we have an X minus, we have a Y minus. So I'm going to write that X minus plus Y minus. And that's just a matter of filling in the blanks where the numbers go. The h value, the x coordinate of the center, is 0. The y coordinate of the center is also 0. And the radius we're told is 7, so we have a 7 squared on the right. This cleans up very nicely. Unless the circle is centered at the origin, then your equations won't be as nice as this first one. But it's the first equation, so they're trying to make it easy on us. X minus 0, that's the same thing just as x. So we have an x squared plus y minus 0. Well, that's the same thing as just y. So we have a y squared equals, what have we got on the right-hand side? 7 squared is 49. So here's my center radius form for the equation of a circle. Any questions there? So we come over here, and we're going to have to type in, we've typed in exponents before, right? Have we? I don't know if we have or haven't. I don't remember. It was a long weekend. So what we'll do is we'll use the hot button. I'd like it better if they say, Pearson said exponent rather than superscript, but they're going to be fancy. Whoever this programmer was, they wanted to sound fancy. So instead of saying exponent, they put superscript. Can you tell there's a little gray box, and then up higher is a little blue box? That's the thing. It's going to give you a blue box there to type in the square. But then you have to get out of the exponent. I do a right arrow before I type my plus, y, superscript, square, right arrow again, equals 49. Any questions there? Okay. And now they want us to graph the circle. What you really need is the center and one additional point. But they're not going to give you an additional point. All you'll know is the center and the radius. Well, if you know the radius, then you can determine a second point. Just go to the center and count 7 units in any direction. Now, can you count diagonal units? Can you count 1, 2, 3, 4 diagonally? No, it's either up, down, left, or right. So I'm going to enlarge the graph. Okay, we got to choose the tool. Which one looks like a circle? There's only one tool there that looks like a circle. Maybe this thing right there? There it is. If you hover over it, it says circle tool. And if you have that bionic eye, you can tell there's a blue center and then a blue additional point. That's what you need. You're going to need the center, and you'll need one additional point, and you'll find that additional point because of the radius. So you click the circle. It says to plot the center. Well, let's see. Is that it? Y'all see where it says 0, 0 there above the V-shaped figure? So there's the center, 0, 0. And now look at this as you move out your cursor. You're drawing every possible circle that's centered at 0, 0. They want us to plot another point. Well, to plot another point, we know the radius. So the radius was 7. So we count 7 units. You can go up, down, left, or right. I think I'll just go to the right. So if we're going 7 units to the right, is that it? No, I need to go 1 more unit. Is that it? No, I think I accidentally moved down, didn't I? Is that it? There it is. And we set these little huge points there still tickle me. Small things amuse me, you might say. Oh, look at that. We saved it. It transferred it over. We check our answer. So, any questions there? A very, very nice graphing tool for this class. And it's especially nice when it's centered at the origin, because it makes it, the counting for the radius, it makes it easier. Any questions? Number 2. Well, we couldn't stay centered at the origin forever, so we're going to find the center radius form of the equation of the circle. This is number 2. Let me write it down. The center is at -3, 4, and the radius is 3. Same instructions. Write the equation first and then draw the graph. What number is acting like h in this case? -3 is my h value. What number is acting like my k value? 4. I agree. So we have x minus y minus, we have that square. So what's going to go after the x minus? Okay, the h value, which is a -3. What's going to go after the y minus? The 4. And what's going to be squared on the right-hand side? 3, that radius value they gave us. And there is a little bit we can do here to clean this up. Watch these parentheses, what's happening inside the parentheses. The equation, the formula, if you will, had an x minus on it, but when you stuck in that -3, what's that about to become? A positive, good. So we have an x plus 3 quantity squared. Here, that just stays a y minus 4. And what have we got on the right? 3 squared is 9. I agree. So we're boxing in. There's the equation of the circle. And we're going to have to type that in. Is everyone caught up? Oh. So we come over here. We have to type in our center radius form. And I just used the parentheses from the keyboard. Left parenthesis, x plus 3, right parenthesis. And I need my superscript, my exponent key, right there. There's a square. Don't do this. You want to do a right arrow, tab, or click on your mouse, get out of that exponent before you type plus. And then it's a left parenthesis, y minus 4. Oh, by the way, shift up arrow at the same time. Do y'all use the little key shortcuts, or you just use the hot button? This thing here, the shift and the up arrow is the shortcut for accessing the exponent. You type the square, but you don't put the equals there. You got to do another right arrow. Oh, wait a minute, I didn't put my equals. 9. Is that what I wanted to type? Yes, yes. So now we're going to draw the graph. Oh good, it's not so tight in here. We have the first thing we have to do, this is a circle, so we click the circle tool, and then we plot the center. The center was -3, positive 4, -3, positive 4, right there. And now it wants you to plot one additional point. Well, we can go 3 units up, down, left, or right. It makes no difference to me. Hey, if we're at -3 on the x-axis, and we count 3 units to the right, where are we going to wind up? Aren't we going to be on the y-axis? There it is. I counted 3 units to the right. And notice, If you'd gone 3 units up, you'd still get the same circle. If you'd gone 3 units to the left, you'd get the same circle. 3 units to the right, the same circle. You plot the circle, and then whatever the radius is, that's how many units you move. Either up, down, left, or right, whatever's easiest for you. Save it to transfer it back to the original grid and check your answer. Any questions there? Okay. Let's see. Number 3. A similar type. They give us the center is at the point 5, -3, and the radius is 6. So let me write this down. Here's number 3. They give us the center is at the point 5, -3, and the radius is 6. What number's acting like H? 5, I agree. What number's serving as K? -3. And my radius is 6. So we have an X minus, Y minus, oh goodness. So what number's going to go after the X minus? The 5, I agree. Y minus, what will we have here? -3, and what number are we squaring on the right? 6. So once again, we can clean this up pretty nicely. X minus 5, we'll just leave that as X minus 5. Don't forget the square. But what are we going to have to do with that Y minus and -3? Make it a +3. And 6 squared is, okay. Before long, they're going to start giving us the equation, and we'll have to go backwards to determine the center and radius. So notice something. As long as the equation's in center radius form, what you see inside the parentheses, that's not the center. Because remember, center radius, that formula had minuses attached. X minus and Y minus. So what you see inside the parentheses is the opposite of the center. I see a -5. Well, the X coordinate of the center is a +5. I see a +3. The Y coordinate of the center is a -3. So when you're going from center radius back to the center, what you see inside the parentheses is the opposite of the center. Change sign to get the center. Same thing's true here. You see a +3, but what's the X coordinate of the center? A -3. You see a -4, what's the Y coordinate of the center? A +4, and that will be significant. Now, if you're given center radius form, and you need to determine the radius, you're going backwards. So what are you going to have to do to the number on the right to undo that squaring effect? Take the square root of 36, which is 6. Take the square root of 9, which is 3. So when they start giving us the center radius form, and you're ready to go backwards to the center and radius, change sign, take the square root. That's one of those phrases. Change sign, take the square root. I've said it so many times over the past 30-something years that I suppose one day when I'm sitting in a nursing home with all my little brain cells gone, there's certain little things that I'll just be saying, sitting there as a, as I, live out my twilight years, I'll be sitting there, and the employees, I can see them at the nursing home. Oh, Mr. Precella, he's rambling incoherently, and I'll be saying things like, change sign, take the square root, and stuff. I have these little phrases. These little phrases connected with logarithms that, one day I'll be saying that. I won't remember anything else. I won't remember what I had for breakfast, but I'll remember change sign, take the square root. Anyway, let's go on. This is a long assignment, so we can't get distracted, and y'all are trying to distract me. It's clear to me that that's what y'all are trying to do. X minus 5. Remember, it's a shift up arrow if you don't want to bother with the hot button. Square, right arrow, plus, left parenthesis, y minus 3. Oh, wait a minute. No, it's y plus 3, isn't it? Plus 3. Shift up arrow, square, equals 36. Is that what I wanted to type? Yeah. And now, let's see. We click our circle tool. They want us to plot the center. The center was 5, -3. Right 5, down 3. Is that it? Oh, nope. I moved it. There. Click it. And now I need one other point. My radius was what? 6. So I'm going to have to count 6 units. It doesn't matter if we go up, down, left, or right. I think I'll go to the right 6 units. That was at what number there? That's 5. So we're going to move to the right 6. 5 plus 6, I better be at 11. Is that it? Yes. I plotted the center. I counted 6 units to the right, but if I'd gone 6 units up, down, or left, it would have still been the same circle. Save it. Check answer. Any questions? Well, I keep thinking they're going to give us one before they give us the equation and want us to go back to the center and the radius, but not yet. Look at number 4. It's the same type. They give us the center. This time it's centered at -2, 0. And the radius is 7. And we have the same instructions. Write the equation and then draw the graph. Well, no, they don't ask us to draw the graph, but they must want. Oh, yes, they do. Right up here. Yeah, they do ask us to graph it. So it is the same instructions. What number's acting as H? -2 as K, 0, and we know that our R value is 7, so we have X minus, Y minus, and what number's going to go here? -2. Here and here. Oh, I mean in here. I pointed at the 7, didn't I? I can clean up this first term, the x minus -2 quantity squared. How am I going to write that? Okay, the minus and negative becomes a plus, so x plus 2 squared plus y minus 0. This is really nice. That's just y, so we have plus a y squared equals, and on the right, 49. Any questions there? That is a square. It looks weird with those little marks above it, but that's just a square. So x plus 2 squared plus y squared equals 49. Get out of that exponent plus, get out of that exponent equals 49. So we click the circle tool, then we plot the center. The center was at -2, 0. Is that the point I wanted? I think I love it when the center is on one of the axes. It makes the counting easier. I think I'll just go up, what was this radius, 7? I'll go up 7 units. Is that it? Yes, it is. I counted up 1, 2, 3, 4, 5, 6, 7. Save it, check answer. Any questions there? Look at this, number 6. All they want us to do is to graph the circle, and they're giving us the equation. This is number 6. Let me write that down. X minus 1 quantity squared plus y plus 7 quantity squared is equal to 4. So here, that's what I've been warning you about. They have not given us the center and the radius. They didn't give us the center and radius. So they gave us center radius form. So what did I say we're going to have to do? Is the x-coordinate of the center a -1? Change sign, change sign. That you see a -1 inside the parentheses. That means the x-coordinate of the center is a +1. What about this +7 here? It becomes a -7. The signs you see inside the parentheses are exactly the opposite of the center. Now we want the radius. The radius is at 4. What are we going to have to do? We're going backwards. To get the radius, you take the square root. The square root of 4 turns out to be 2. And that's all you need to draw the graph of the circle. You use that center radius form they gave you to determine the center and the radius, and we're ready to graph. So, I'm going to pop out that graph, and I'll click the circle tool once again. And the center was 1, -7. Is that it? 1, -7? Yes. And then the radius is 2. I think I'll just move 2 units to the right. 1, 2. Save it. Oh, there it is on the original grid. Any questions there? That center radius form sure is nice. As long as someone doesn't decide to go through and remove parentheses, it's easy to determine the center and the radius. Y'all can tell me the center probably without me even having to write it down. What's the center? Here on number 7. Yeah, I think that's right. Okay. So, and this is a 5. It looks funny, but it's a 5. That is a 5. And then I made it worse, didn't I? That's like an F with a circle there, 5. So what did y'all say the center was? -5, change sign. -1, change sign. And the radius, you take the square root of 4, which is 2. And it's just a coincidence that 6 and 7 both had a radius of 2. So we come over here. All we got to do is draw the graph. So we click the circle tool. We plot the center, -5, -1. Is that the point? Is that -5, -1? Yes, it is. And now we need another point. The radius is 2. How about we count up 2 units? 1, 2. Realize if you'd counted 2 units to the right, you would have gotten there. If you counted 2 units to the left, you would have gotten the point where my cursor is. If you counted 2 units to the left, you'd get right there at -7. So it doesn't matter. Just either up, down, left, or right, whatever you feel like doing. Check your answer. Any questions there? So far, everything is going pretty easily. We're already up to number 7. Things are moving pretty easily now. So far. But there is a big wrinkle in all of this. Let's suppose someone decided they wanted to remove parentheses. Suppose I'm just going to use this number 7 as my as a demonstration, just to show you what I'm talking about. Let's suppose we had, I'm going to say, consider the equation x plus 5 quantity squared plus y plus 1 quantity squared is equal to 4. Suppose someone wanted to get rid of that x plus 5 squared. What are we going to have to do? I'll tell you right now, it's not just x squared plus 5 squared. We have squared sums and differences since the second class meeting. I remember we had something like a 2 plus 3i that we had to square. If you have a sum or difference being squared, what's the trick? That square means you have x plus 5 times x plus 5. That's what we mean by x plus 5 squared. We have 2 factors of x plus 5. Plus, apply that same logic to y plus 1 squared. What does that mean? What have we got? Y plus 1 times y plus 1. And now we go through FOILing out x plus 5 times x plus 5. First, x times x is x squared plus outer x times 5 is 5x. What's the inner product? Another 5x. The last product, 5 times 5 is, so that cleans up to be x squared plus 10x plus 25. Now let's expand the y plus 1 times the y plus 1 by FOILing that out. Y times y first is y squared plus y times 1 is 1y plus the inner product is another y plus last 1 times 1 is 1 equals 4. We may as well clean up the y terms. That says what? We have a y squared plus a 2y plus 1. 1y plus 1y gave me the 2y. And let's suppose that we went through and then let's change up the order of the terms. Let's put the square terms first, but in alphabetical order. So x squared would go before y squared. So we have an x squared plus a y squared. Then we have a 10x. We have a 2y. We have a 25 plus 1, that's 26. How about we move this 4 over and combine it with that 26? 25 plus 1 is 26. Let's get a 0 over here on the right-hand side. What's my constant going to be there? Okay, 25 plus 1 is 26 minus 4. I agree with the plus 22. Did y'all follow my logic here? What we have here, where the parentheses have been removed and all the like terms have been combined, and you have it set equal to 0. That's called either expanded form or standard form, depending on what book you're looking at. Expanded or standard form. And I'll tell you right now, there's really no time that I can think of in this course when this expanded form is a good thing. Now, if you were in a Calculus 2 class doing some implicit differentiation, then okay, I can see going through this, okay, but or related rate problems, say there's the radius is increasing at some rate per hour, rate per minute, but really from an algebraic point of view, there's nothing nice about this expanded form. Look at center radius form. If you need the center and the radius, all you do, change sign, take the square root. Is there an easy way here just to look and tell center -5, -1, radius 2? What they're going to be doing now, they're going to give us expanded forms. And now we're going to have to go back creating perfect square trinomials for x and for y, so that it'll be written in the form quantity squared plus quantity squared equals a positive number. We're going to have to go backwards from this step here all the way back to the original center radius form. This process, x plus 5 quantity squared, that's called a perfect square trinomial. It's x squared plus 10x plus 25. Any trinomial that can factor as a binomial squared is called a perfect square trinomial. So we're going to have to create perfect square trinomials for x. We're going to have to create perfect square trinomials for y. And it's not that rigorous. Oh, I'm pointing and pointing, but y'all don't see what I'm pointing at. Y'all didn't see any of the stuff that I was writing, did you? And you didn't tell me. Well, that's fine. Yeah, okay. Here's all the stuff I was writing, and my quiet class didn't tell me. They couldn't see what I was writing. So let's go through it, and let's go through another one. Okay. I'm going to use problem number 6. I'm going to use problem number 6 here. X minus 1 quantity squared plus y plus 7 quantity squared is equal to 4. If you want to expand center radius form, and as I've said, there's really no reason that you should want to do that in this class, but it's a good way to see what's happening when we start trying to go backwards. X minus 1 squared, that's an x minus 1 times an x minus 1 plus y plus 7 squared. That's a y plus 7 times a y plus 7 is equal to 4. So y'all heard me talking through this. Remember, we had a colleague, I remember Tranya Aquino. She could do that. It was amazing. I'd stand outside her class and watch. She could talk through the problem, and she'd see the stuff in her head, and she'd be telling the students what to write down. It was really very impressive, okay? But me, myself, I always have to write the stuff down. Let's FOIL this out. X minus 1 times x minus 1. First, x squared. Outer, it's an x times a negative 1. So inner, same thing, okay. Last, and then we can combine the negative x minus x to give us x squared minus 2x plus 1 plus, let's FOIL out the y plus 7 times the y plus 7. First, outer, I agree, inner, another 7y, last, and, well, we have a 7y plus 7y that we can combine to give us a plus 14y. So we have y squared plus 14y plus 49. We still have that equals 4. X squared minus 2x plus 1. That trinomial is called a perfect square trinomial because it factors just as a binomial squared. A binomial times itself. The same thing's true for y squared plus 14y plus 49. It factors as y plus 7 times y plus 7, so that's a y plus 7 quantity squared. And now, let's regroup. X squared, we'll put the square terms first. X squared plus y squared. We'll put them in alphabetical order, so x goes before y. Then the unsquared variables, we have a minus 2x and a plus 14y. We have a 1 plus a 49, that's 50, but we're going to have to move that 4 over. What are we going to do to move that 4 over? So we have a 50 minus 4, that's a plus 46, is equal to 0. This is the thing I call expanded or standard form. I usually say expanded. And there's nothing desirable about this form in terms from an algebraic point of view. You can't just look and easily change sign, take the square root. Can you just look there easily and tell what the center or radius is going to be? You're going to have to go backwards. You're going to have to group the x squared and the x together. But look at that. Does 1 even pop up here anywhere? You're going to have to find this 1. What about that y squared plus 14y plus 49? You have the y squared plus the 14y, but do you see the 49? You're going to have to find that 49, okay? And to do that, we need to discuss perfect square trinomials. Perfect square trinomial. A perfect square trinomial factors as a binomial squared. Binomial squared. By that I mean a quantity squared. That's what I mean by binomial being squared. We already have a couple of perfect square trinomials that we're looking at. X squared minus 2x plus 1. That factors as x minus 1 times x minus 1, which is x minus 1 squared. The same logic can go for y's as well, but I think I'm going to use an x here just when those little y tails get a little messy, so I think I'll just use an x. So x squared plus 14y plus 49 will factor as x plus 7 times x plus 7, and that's an x plus 7 quantity squared. Here's another perfect square trinomial. X squared plus 10x plus 25. To be a perfect square trinomial, for it to be a perfect square trinomial, I'll give you a hint. That last number has to be a perfect square. The last number has to be a perfect square. How can we factor this? It's a trinomial. I'm going to write my two sets of parentheses. Well, x squared, that's an x times x. What do we know about the signs inside those parentheses? We're trying to factor x squared plus 10x plus 25. Okay, they're going to be plus and plus. If the last sign's a plus, you have two of the first signs. And then 1 times 25 or 5 times 5, remember, for a simple trinomial, you're going to have to get the pair that adds together to give you 10. So it can't be 1 times 25. It has to be 5 and 5 for an x plus 5 quantity squared. Any questions on my logic so far? You may not see where I'm going with this, but any questions on how I'm factoring these? Okay. X squared plus 8x plus what? When we're going backwards, remember I said like that 1 and that 49, it doesn't appear in the original problem. You're going to have to find the perfect square to put there so that you can factor the trinomials as perfect squares. So I want to factor this as a quantity squared. Well, with that plus and that plus there, I think we can assume, safely assume that's going to be a plus inside the parentheses. I think if you look at this previous line, that's probably the best example for you to see the pattern. You have an x squared plus a 10x. You don't know what number is going to be here. The only number you're seeing is that number right there, 10. What do you do to 10 to generate the number 25? There are two steps. What do you do to 14 to generate that number 49? How do you figure out the perfect square constant? Notice the way we were going through, when we were going through expanding, we started off with a 7y. But then we got another 7y when we did the outer and the inner. But the first product we got that y squared, then the outer product was a 7y. We picked up a second 7y with the inner product. What did we do? We had a 14. So if you want to go back to 14, from 14, well, it looks like you took half of 14 over 2 7s. You got a 7. And then what do you do to 7 to generate that number 49? Not square root. You're going, I think you're squaring it. You took half of 14, that gave you 7. 7 times 7, 7 squared, gave you the 49. Does that work here? Oh, by the way, since you're squaring, that last number there's always going to be positive. So I don't have to worry about that sign. Half of 2 is 1. 1 times 1 is 1. What about down here? What's half of 10? 5 squared is 25. Half of 8 is 4. 4 squared is 16. So the perfect square we need is 16. What number is going to go inside the parentheses? How do you factor x squared plus 8x plus 16? Look at x squared plus 10x plus 25. You don't need to look at this stage here. You have an x and a plus. What's that constant inside the binomial? Okay, I agree. It's going to be a 4. It doesn't matter how you look at it. You can either think, oh, I'm taking half of 8, or you can say, take the square root of that constant 16. But you take half of this number and then square it to determine that perfect square constant. And then it's going to factor in the form variable, sine, half of that number, or the square root of that. My brother says that number is determined by the square root. To me, I go variable, sine, half of that number. Variable, sine, half of that number. Look at, let's see, how about, oh, here's one. I'm going to do it with the y. Y squared minus 12y plus what? That's going to factor variable, sine, so y minus, what number are we going to have to put here? You're going to do two things to 12. What's the first thing you do? Divide it by 2. 12 divided by 2 is 6. And then what do you do to the 6? Here's my scratch paper. 12 divided by 2 is 6. And then you say 6 squared is 36. So there's the perfect square trinomial that we've created. Now we'll factor it as a binomial. Variable, sine, what's going to go after that minus? This half of that number, 6. If you take y minus 6 times y minus 6 and FOIL it out, you're going to get back y squared minus 12y plus 36. What about this one? Suppose we had x squared, let's say, plus 20x. What number would I have to put there to make a perfect square trinomial? 100? I think you're right. You take half of 20, that's 10, and then 10 squared is 100. So that blank there would be 100. How is it going to factor inside these parentheses? Call it out. I couldn't hear you. I agree. X plus 10. Variable was an X. That first sign was a plus. Half of 20 was 10. And that's how we're going to take these standard forms and convert it back to center radius form. And I bet you I've been logged out on for problems where we have to convert standard form or expanded form to center radius form. Here it is. There. Okay. Under Canvas, under Files, I have my Circles PDF there. That's that handout I just gave y'all, but you'll notice this is a lot cleaner, easier to read. And if you look there, hey, let's look at what this handout says before we get start back with the homework. The equation of a circle centered at 0, 0 with radius r is, I think that's that first problem we did today, isn't it? Remember, if h and k are both 0, then it's just an x squared and a y squared. If the center is hk, there's center radius. To find the center and radius of a circle when the center radius form is given, I think this is what I said. Change the sign of the number in the parentheses paired with x. Change the sign of the number in the parentheses paired with y. To find the radius, take the square root of the number on the right side. Yeah, I said change sign, and take the square root. And we have a couple of examples here. The center, here's the equation. Change sign, so 2, negative 5. Take the square root of 49, that became a 7. Yeah, I said that. There's nothing added or subtracted, so the x-coordinate of the center would be 0, and the y-coordinate for the second example would be a positive 8. Yeah, I think we said all of that. So what's new here, to find the center radius of a circle when its equation is written in expanded form. If your circle is in center radius form, when you start expanding, when you start going through removing the parentheses, look at my work here. Here's center radius form. You have an x and a y. When you go through there, you should expect to pick up an x squared and a y squared. There's not a number in front of x or y in center radius form. That means your leading coefficients should always be a 1 when they're in the expanded form. If you FOIL out x minus 1 times x minus 1, you're going to get an x squared. You're not going to get something like a 3x squared. It's just variable times itself. Variable times itself. So the point is that x squared and y squared's coefficients should be 1s. If they're not, if a doesn't equal 1, a is the coefficient of x squared and y squared. If a doesn't equal 1, divide each term by a. Then they said to rewrite the equation by grouping the x terms together, followed by the y terms. Then isolate the constant term on the right side of the equation. Steps 3 and 4, those are those magic steps that we did to create the perfect square trinomials. You divide the coefficient of x by 2, and then you square that number that we found. That's what we were doing here. Divide that coefficient of x by 2, that gave us 10. Square the 10, that gave us 100. So steps 3 and 4 are those magic steps that will give us the constant we need to create the perfect square trinomial. Repeat those steps for the y terms. Factor it as a perfect square trinomial, and after you do that, you should have it in center radius form. And then it's telling you to change the sign in the parentheses to get the center, take the square root to get the radius, and if this thing is a circle, that number on right had better be positive. If you try to take the square root of that number and it's 0, that means you don't have a circle. You have the center point, but you can't move up, left, or right. If this number is negative, when you take the square root, you're going to get an imaginary number. That means you don't even have a point. It's totally imaginary. There is no graph whatsoever. We'll see that in more detail as we work through the rest of the problems. Starting at number 8. Here we go. Oh, X that out. Here we are. Starting at number, I'm having to go back into the assignment. There. Number 8. And I assure you, I've made this sound much worse than it actually is. Let me write the problem down. Find the center and radius of the circle with the given equation. This is number 8. Let me write it down. X squared plus y squared minus 10x plus 4y is equal to 52. X squared plus y squared. They want us to find center and radius. X squared plus y squared minus 10x plus 4y is equal to 52. Okay. Following that little recipe on that handout, what's my A value? What's the leading coefficient? Realize x squared and y squared have to have the same coefficients. So I don't see a number there in front of x squared. What do we assume it is? A 1. So that first step, if a doesn't equal 1, divide each term by a. We just skip over that. Our leading coefficient is already 1. And then the second step, rewrite the equation by grouping the x terms together, followed by the right terms. Isolate the constant term on the right side of the equation. We already have the constant term on the right, so here we go. We're going to group our x terms together. X squared minus 10x. X squared minus 10x. I'm going to do more than just group them together. I know I need a number added in there to create a perfect square trinomial. So I'm going to put my little plus space. And now we'll group the y terms together. Y squared plus 4y plus space. And if our constant term had been over on the left, we'd move it over to the right. Fortunately, it's already on the right for us. We're now ready to create those perfect square trinomials. What do we put here? We want the x terms. Our goal is to get something that factors as quantity squared plus quantity squared. What number are we going to have to put there to create that perfect square trinomial? That's steps 3 and 4. Step 3, divide the coefficient of x by 2. Step 4, square the number found in step 3. Once again, this document is under Files on Canvas, so you can have a nice, clean digital copy, a lot easier to read. So we take half of 10. Here's my scratch work. 10 divided by 2 is 5. You then square 5. 5 times 5 is 25. And notice I don't worry about that sign, because if you said, oh, that's a negative, when you square negative 5, negative times negative, you're still going to get a positive number. So that little minus sign there doesn't really matter. It's just a plus 25. I'd ignore it for this determining that number there. I just take the coefficient part, the number part of the coefficient of x, take half of it, then square the result. And then this is going to factor very nicely. I said these things have a pattern for factoring. It's variable, sine, half of 10 was 5. What's going to go here? Step number 5 says to repeat this process for the y's. So what's going to go in that y blank? Okay, you take that coefficient of y. Half of 4 is 2. 2 squared, you're right, is 4. So we put a 4 there. And this is going to factor as y plus variable sine. What number is going to go here? There's a major problem algebraically, though. We just added 25 to the left side. We added 4 to the left side. This is an equation. Whatever you add to one side, to maintain that equality, what are you going to have to do? Add it to the other side. So that 25, we're going to add that to the right side. And the 4 will have to be added to the right side. 25 plus 52, that's 77, plus 4, what are y'all getting over here? A nice 81. Here's center radius form. This is what we were after. Group the x terms together. Group the y terms together. Move the constant over. Half of 10 is 5. 5 squared is 25. Half of 4 is 2. 2 squared is 4. Those numbers that you're adding in there on the left, you're going to have to add them to the right also. And then notice how nice these perfect square trinomials factor. Variable, sine, half of 10 is 5. Variable, sine, half of 4 is 2. What's the center? What's the radius? Okay, change sign and -2, change sign, I agree. What are we going to have to do to this number to get the radius? Take the square root of 81, which is 9. And the reason you wanted this is so you can draw the graph. You are going backwards. Someone took the equation and expanded it. You're having to go through creating perfect squares. This process of creating perfect square trinomials is called completing the square. And I told y'all we'd be seeing completing the square when we got to circles, and that's what we're doing right now. Let me go back before I get timed out again. All they want me to do, they say to find the center and the radius because they want you to draw the graph. You don't have to type in the center and the radius, just the center. What did we say the center was? 5, -2. Notice the incrementing by units of 2. Each little tick mark there is 2. Wait a minute. 5, -2. Right there. There's the center. And the radius is 9. Let's see. 5. Let's move 9 units to the right. We're at 5. 5 plus 9, that's 14. So we should be at 14. Is that it? No, I think that's 15, isn't it? 5 plus 9, is that 14? There it is. You could have counted 9 units up, 9 units down, or 9 units to the left. I moved 9 units to the right, but you still get the same graph. Any questions there? I imagine there are questions. Let's hold off on questions until we do another one. Okay, here it is, number 9. This one will go faster, I bet you. Let me write down the problem. X squared plus y squared minus 2x plus 8y minus 8 is equal to 0. Let me make sure I didn't miscopy this. X squared plus y squared minus 2x plus 8y minus 8 equals 0. We're going to follow our completing the square recipe. We group our x terms together. That's an x squared. Well, first of all, what's the leading coefficient? 1, so we don't have to divide yet. We don't have to divide. The a value is 1 again, so There will be at least one where that a value is at 1, but here, x squared, group the x terms together, plus skip some space. Do the same thing for the y terms. We have a plus y squared, plus 8y, plus skip some space. Uh-oh, what are we going to have to do with that minus 8? This number right here, what are we going to have to do with it? Okay, so we have a positive 8. Now we're going to perform those two magic steps that create perfect square trinomials. We take the number 2. What do we do to the number 2? Divide it by 2, which gives us 1, and then you square 1. 1 times 1 is still 1. You add the 1 to the left. I think it's safest if we go ahead and add the 1 right now while we're thinking about it. Otherwise, I'll forget about it. What number is going to be added beside the y terms? Y squared plus 8y. 16. You took half of 8. Half of 8, here's my scratch work. I'll do it right here. Half of 8 is 4. And then you say 4 squared is 16. So you put the 16 here. Go ahead and add it to the right now so you don't forget about it. Now we can factor the perfect square trinomials. We need this to factor as a quantity squared. What will I have inside these parentheses? Okay, what's the first thing I'm going to write? X, sign, number, that's right, variable, sign, half of that number. Now the y parentheses. I agree. Did y'all hear that? Variable y, the sign is a plus, half of 8 is a 4. Hey, you can tell me the center right now. What's the center of this circle? Assuming it is a circle. I couldn't hear you. That's right. Change sign, change sign. What have we got on the right-hand side? I think that's 9 plus 16. That's a 25. So the center, 1, negative 4. What's the radius? You take the square root of that number, and that gives you a 5. Any questions there? We completed the square for the x's to create the perfect square trinomial and get it factored as x minus 1 quantity squared. We completed the square for the y's to get a perfect square trinomial of y plus 4 quantity squared. We took the square root of the number on the right to give us the radius. Is it getting easier? Okay. So we click our circle tool. The center was 1, negative 4. Is that 1, negative 4? Do y'all see in that yellow box there underneath? Oh, I moved it. Let me move it back. There it is. 1, negative 4. That's what I'm looking at as I'm moving my cursor around. I'm not really looking at where this little pointer is at that stage when I'm plotting the circle. Now, what's the radius? We said the radius was 5. So we're at 1. Let's move 5 units to the right. 1, we're at 1 on the x-axis. 1 plus 5, that gets us at 6. There's my circle. Check answers. Any questions there? Here, oh, we're not graphing here. We're just told to find the center and the radius of the circle. And let me write down the equation. Okay, let me write this down. Remember, I said the leading coefficient needs to be a 1. We need a 1x squared and a 1y squared for this little recipe of ours to work. So y'all be thinking about what we're going to have to do first. X squared, 4x squared plus 4y squared plus 32x minus 24y plus 84 equals 0. And here all they want us to do is find the center and the radius. Hold on, let me do something. Back over here, minimize that. Oh, well, where is it? I know I had it here somewhere. I thought I had it. Did I close it earlier? I guess I did. Well, shoot. That's okay. Don't forget. Oh, there it is. Here's that handout I gave you. If A doesn't equal 1, what are we going to have to do? Divide each term by A. What is A in this problem that I just wrote down? 4. Divide each term by 4. That's the same thing as multiplying both sides by 1/4. Divide by 4. So we now have 1x squared plus 1y squared plus 32 divided by 4, that's an 8x. What are we going to have for y? Okay, so we have a minus 6y plus 84 divided by 4, is that a 21? Equals 0 divided by 4 is 0. Okay, I thought I'd surely get someone to say undefined. Remember, it's okay to have a 0 on top. It's a 0 on the bottom that's no good. So now we group our x terms together. We have an x squared plus an 8x plus, skip some space, plus you have a y squared minus 6y plus, skip some space. What are we going to have on the right side? Be careful. Negative 21. What number are we going to add beside x squared plus 8x? What number is going to go here? 16. 8 divided by 2 is 4. 4 times 4 is 16. Add it to both sides. You're going to maintain that balance. What number is going to go beside y squared minus 6y? I couldn't hear you. 9, I agree. 6 divided by 2 is 3. 3 squared is 9, so we go plus 9, plus 9. How will we factor x squared plus 8x plus 16. Variable, sign, number. Okay, I agree. Remember, the variable is the variable that you start with. The sign is the first sign you see. That constant is half the number. Variable, sign, half the number you see. Plus, now let's do the same thing for the y's. Here, sign, number. Well, be careful, it's variable, sign, half the number. Remember, my brother says variable, sign, take the square root of that last number. It's going to be the same thing. It's either half of the second number or the square root of that last number. And what are we going to have on the right-hand side? Negative 21 plus 16 is a negative 5 plus 9. That gives me a positive 4. A nice radius, at least. What's the center? Negative 4, comma, 3. I agree. Change sign to get the center. The radius. You took the square root of that number there. The square root of 4 is 2. Any questions? If the number in front of x squared and y squared is not a 1, the first thing you have to do is change it so that it is a 1. Because you can't, for center radius form, you can't have something like 3x inside the parentheses. It can only be an x. And x times x is going to give you an x squared. It's not going to give you a 4x squared. Any questions there? Oh, goodness. Okay, so come over here. Oh, yeah, this, so we're not having to draw the graph here. They just want us to select the correct center and radius. Let's see. No, that's not it. Let's see. Negative 4, 3, radius 2. It looks like response B. Any questions there? Number 12. We'll go back to number 11 in a minute, but number 12. Decide whether or not the equation has a circle as its graph. If it does, give the center and radius. If it doesn't, then describe the graph. The only way you can decide if this equation represents a circle is to write it in center radius form first. So the first thing we're going to have to do is write it in center radius form. And then we'll be able to make a decision on whether it's a circle based on the radius value. Based on the radius value. To find the radius, you take the square root of that number on the right side. Notice, I'm going to blow this up a little bit. Notice, if r is 0, you have your center point, but you can't go up, down, left, or right. So the graph is just the center point. If you take r and you get the square root of a negative number, if you get imaginary, there's not even a center point. So keep that in mind. You still have to write the equation in center radius form to determine if you have one of these special cases. After everything I've been talking about, watch this not be a special case. Let me write the equation down. This is number 12. X squared plus y squared plus 4x minus 6y plus 14 is equal to 0. The way they ask that question, decide whether or not the equation has a circle as a graph. It could give you the impression, oh, you're just going to look there and, oh, no, it's not a circle. You can't tell. You have to write it in center radius form first. Then you can make a decision based on what the radius is. If it's 0, if the radius turns out to be 0, then you would have Option B, the graph is just a point. If the radius turns out to be imaginary, then you don't have a graph. There is no graph. Now, whoever programmed this was trying to sound fancy. That would be response D. The graph is non-existent. In other words, there's no graph. I know, if I were guessing right now, I know it can't be response C. Response C, the graph of the equation is a line. Can lines have x squares and y squares? No. So I know they just wanted 4 options. That's why they've stuck on the graph as a line. But we know that's not a line, because otherwise there wouldn't be, if it were a line, you couldn't have x squares and y squares. Let's go through completing the square to get this thing written in center radius form. And let me make sure I didn't miscopy it. X squared plus y squared plus 4x minus 6. Okay. Okay, here. So what do y'all think? Is this like number 10? Am I going to have to divide first? No, the leading coefficients are already 1. So we group the x terms together. X squared plus 4x plus, skip some space. And then the y terms together. That's a y squared minus 6y plus, skip some space. What number will I have on the right-hand side? Negative 14. Pick that 14 up and move it over. What number is going to go beside x squared plus 4x? I agree with 4. Just to remind you of what we were doing. You take half of that coefficient of x, and then you square it. 2 times 2, that gave us the 4 that we add here. And to maintain the equality, if you had 4 pounds, to one side of the scale, to maintain the balance, you better add 4 pounds to the other side. What number are we going to add beside y squared minus 6y? I agree. 6 divided by 2 is 3. 3 squared is 9. So I put 9. If I add 9 pounds to the left side, I better add 9 pounds to the right side. Let's factor our x terms. I'll get us started. There's my parentheses and the square. What do I have inside it? X plus 2. I agree. Variable, sign, half of that number. Plus, here, I agree with that. Y minus 3. Y'all are on the ball today. The vocal minority, I should say, is on the ball. Variable, sign, half of that number. What have we got on the right-hand side? That's a negative 14 plus 13 is a negative 1. I'm just going to ignore this portion right here for the time being. I'm going to try to determine my radius. You take the square root of the number on the right-hand side. The square root of negative 1, we know the square root of a negative number is imaginary. So there is no graph. I guess it's just an imaginary graph somewhere out there at the universal point. Any questions there? Not even a point. If you take, using our method to determine the center, what would the center be? The center, if you tried to determine the center, you'd get a negative 2, and what's the other number? 3. If you plugged in negative 2 and positive 3, you'd get negative 2 plus 2. That's a 0. 0 squared plus 0 squared. 0 plus 0. Does that equal negative 1? The way we're squaring these things, even if it's negative on the inside, when you square it, you're not going to get a negative number. Non-negative plus non-negative can never equal a negative number. If your radius turns out to be imaginary, you have no graph. And we summarize that on that document under Files, that thing I gave y'all. That's what I'm trying to say right here. If r is imaginary, that happens when you take r equals the square root of a negative number, then there's no graph, not even a point. So all that work, and we're going to choose option B. Think about it. There's no ordered pairs that you could plug in for x and y to make the left side equal the right side. There is no graph, not even a point. Any questions there? Let's go back to number 11. Same instructions. Let me write it down. X squared plus y squared plus 8x plus 2y plus 8 is equal to 0. They want us to decide if it's a circle. I know one option that cannot possibly be correct. I see those squares, so what do I know is not the correct option? A, B, C, or D? B. It can't be a line because lines don't have x squares and y squares in them. So it's either A, B, or D. If that radius turns out to be positive, that's going to be response A. We'll have to type in the center and the radius. In order to be just a point, what would the radius have to be? You have a center. What would the radius be if it's just a point? 0, you're right. I mean, you said it, just dawned on me, you'd already answered it. If the radius turns out to be 0, that's when you have the center point. All they want is just for you to say it's a point. But I'll tell you what point it is. It's the center point. So, let's go on. Let me make sure I didn't miscopy this problem. X squared, y squared, 8x, 2y. Oh, goodness. Switch there. What am I going to do first? Do I need to divide? No, the leading coefficient's already a 1. So just tell me, what will I do next? Okay, so we're going to put the x's together. X squared plus 8x plus skip some space. And then put the y's together, okay? Y squared plus 2y plus skip some space. Then what am I going to do? Okay, move that constant over to give me negative 8. Good. What number is going to go in the blue blank? X squared plus 8x plus x squared plus 8x. What number is going to go here? 16, I agree. Half of 8 is 4, and then you go 4 squared is 16. So you put the 16 there, and to maintain the balance, you better stick it on the other side too. What number will go there beside the y squared plus 2y? 1. 2 divided by 2 is 1. 1 squared is 1. So I add 1 and I add 1. Now we can factor the x terms as a perfect square. Factor the y terms as a perfect square. What are we going to have inside the x parentheses? X plus 4, I agree. Variable, sign, half of that number. What's going to go inside the y parentheses? Y plus 1, I agree. Variable, sign, half of that number. What have we got on the right-hand side? Negative 8 plus 16 is 8 plus 1. I agree with 9. Is this going to be a no graph situation? No. Is it going to just be a point? No. It's a circle. That number is positive. Positive. If that number on the right is positive, then you have a circle. If it's positive, then it's a circle. What's the center? Change sign, radius. The square root of 9, I agree, is 3. So this is response A then. It is a circle. The center is negative 4, comma, negative 1, and the radius was 3. Any questions there? One more, number 13. Okay. Decide whether it's a circle. If it is, give the center and radius. If it isn't, describe the graph. X squared plus y squared minus 6x minus 6y plus 18 is equal to 0. X squared plus y squared minus. Okay. Now this is the last one we'll be doing, so do I need to divide through like I did on number 10? Do I need to divide through? No, the leading coefficient's already a 1, so what do? Group the x terms together and group the y terms together. X squared minus 6x plus skip some space. And y squared minus 6y plus skip some space. What are we doing with the 18? And that'll give me a negative 18. What number is going to go in the x blank? X squared minus 6x. 6 divided by 2 is 3. 3 squared is 9. Add it to both sides. What's going to go in the y blank? Y squared, oh, well, it should be obvious what number is going to go here. Same thing, since the x and y coefficients are the same. And we can factor the x terms as x minus 3, variable, sign, half of that number, quantity squared, plus, now the y terms. Y minus 3, good. What have we got on the right-hand side? So we have a center at 3, 3. What's our radius? Okay, the square root of 0 is 0. That means you have a point. Here's your XY grid. You go 3 right, 3 up. There's the center. There's your center point. But how many units do you move up, down, left, right? None. You're just left with that center point. That's all you have. So I want you to say that the graph is a point. We can be more specific though. We know it's this center point, the point 3, 3, but all they want us to say. Any questions there? I think number 14 goes back to old cut point method I told you all when we did that. Cut point and quadratic formula. It's never going to, well, it'll go away when the class is over, but it's not going to go away until the end of the semester. Any questions there? Okay, let me stop the recording.